November 12, 1942, 3:30 p.m., Richmond, California. The champagne bottle swung toward the bow of the SS Robert E. Peary as 1,000 workers, naval officials, journalists, and rival shipyard owners held their breath. 4 days, 15 hours, and 29 minutes earlier, this vessel had been nothing but scattered steel plates and prefabricated sections, waiting in workshops across the Richmond yard. Now a complete 441-foot Liberty ship, 14,245 tons of welded steel, sat poised to enter San Francisco Bay. The crowd wasn't here to celebrate. They were here to watch it fail. Vice Admiral Emory S. Land stood near the launch platform, his face carved from skepticism. Beside him, naval architects from Bethlehem Steel, Newport News, and Todd Shipyards clutched notebooks filled with technical objections. Journalists from Fortune, Life, and the San Francisco Chronicle positioned cameras to capture what many assumed would be either a publicity stunt or an outright disaster, because nothing about this ship made sense. Traditional maritime wisdom, accumulated across centuries, refined through generations of master craftsmen, held that a cargo vessel this size required a minimum of 6 to 8 months to construct properly. The British Admiralty had been building ships for 500 years and had never approved construction timelines shorter than 120 days. Yet Henry Kaiser, a man who had never built a ship in his life, claimed to have assembled a fully operational ocean-going cargo vessel in less than a week. The hull before them wasn't a shell. It wasn't a demonstration model with missing systems and hollow compartments. Naval inspectors had spent the previous 12 hours crawling through every deck, every bulkhead, every welded seam. The Robert E. Peary carried complete electrical systems, functioning steam turbines, installed cargo booms, navigation equipment, crew quarters, galley facilities, and a propulsion system ready to drive the ship at 11 knots across any ocean on Earth. Every system operational, every inspection passed, every safety certification approved. Built by workers who had learned to weld 2 weeks ago. The launch chains released. The hull began sliding down the ways toward the water. Silence held the crowd as 14,245 tons of steel entered the bay, water rising along the hull plates, testing every weld, every joint, every structural decision that traditional shipbuilders had condemned as reckless. The ship floated, level, stable. Perfect. No leaks, no structural failures, no catastrophic welding fractures. The Robert E. Peary sat in the water as though it had been built by maritime masters across 8 months of meticulous craftsmanship, not assembled by farmers and housewives in less than 5 days. Admiral Land's expression shifted from skepticism to something else, something closer to shock. Or perhaps the beginning of understanding that everything his profession believed about shipbuilding limits had just become obsolete. The question hung in the salt air above Richmond Shipyard No. 2, unspoken but undeniable. How did untrained civilians, led by a man who had never built a ship, just do what every maritime expert in America said was impossible? Before we continue, click that subscribe button, like this video, and let me know in the comments where you're watching from. It brings me great joy knowing that these war stories and lessons get to people all over the world. Your support helps us bring more thrilling war stories, and trust me, you won't want to miss them. Now, let's get back to the story. The answer would rewrite naval warfare, shatter industrial orthodoxy, and prove that the greatest limits aren't physical. They're the ones experts build inside their own minds. December 27, 1940. Washington, D.C. Henry J. Kaiser walked into the offices of the United States Maritime Commission and signed a contract promising to deliver 30 cargo vessels for the British government within 2 years. He had never built a ship, not one, not even a rowboat. At 58 years old, Kaiser had spent his entire career moving earth and pouring concrete. He had built Boulder Dam, transforming the Colorado River into the largest reservoir in America. He had constructed Grand Coulee, Bonneville, and Shasta, massive concrete monuments that proved human engineering could bend geography itself. His crews had paved highways across the Sierra Nevada, built bridges over impassable gorges, and turned theoretical blueprints into physical infrastructure that redefined the American West. But ships, maritime construction, naval architecture, completely foreign territory. The traditional shipbuilding establishment watched Kaiser's contract signing with barely concealed contempt. Men who had apprenticed for decades under master shipwrights, who carried lineages of maritime expertise stretching back generations, who understood ship construction as craft passed father to son since before the Revolutionary War. These men saw Kaiser as a dangerous amateur playing at serious business. The Todd Bath Iron Works, one of America's oldest and most prestigious shipyards, agreed to partner with Kaiser on the contract. Not out of respect, out of necessity and condescension. The British needed ships desperately. The Maritime Commission needed yard capacity. And Todd's executives assumed their expertise would compensate for Kaiser's ignorance, that they would build the ships while Kaiser provided financing and stayed out of the way. They were catastrophically wrong. Trade publications barely concealed their mockery. Marine Engineering and Shipping Review ran editorials questioning whether dam builders understood the difference between concrete and seawater. Veteran naval architects exchanged knowing glances at maritime conferences, dismissing Kaiser as another industrialist who would learn expensive lessons about why shipbuilding remained the province of specialists. What none of them understood, what they couldn't see through their decades of accumulated expertise, was that Kaiser's complete ignorance of maritime tradition would become his most powerful weapon. He didn't know that ships had been built essentially the same way for thousands of years. He didn't know that welding was considered dangerously experimental. He didn't know that shipyards were supposed to look a certain way, operate with certain methods, employ workers with certain pedigrees. He didn't know that what he was about to propose was impossible. And because he didn't know the rules, he felt no obligation to follow them. Kaiser looked at shipbuilding not as sacred maritime craft, but as an engineering problem. Steel needed to be shaped, joined, and assembled into a hull that would float and carry cargo. The ocean didn't care whether craftsmen or factory workers welded the seams. Physics didn't respect tradition. While traditional shipbuilders saw centuries of proven methodology, Kaiser saw inefficiency. While they saw essential complexity, he saw opportunities for simplification. While they saw skilled labor as irreplaceable, he saw tasks that could be broken down, systematized, and taught. The establishment dismissed him as reckless. They should have recognized him as dangerous. Because Henry Kaiser was about to prove that expertise can become a prison, and sometimes the most revolutionary innovations come from people who don't know enough to understand what's supposed to be impossible. February 1941. Ford River Rouge Plant, Detroit, Michigan. Clay Bedford stood on the observation platform overlooking Ford Motor Company's massive assembly line, watching a revolution in motion. Kaiser's chief engineer had come to Detroit on what traditional shipbuilders would have considered a fool's errand, searching for shipbuilding inspiration in an automobile factory. But Bedford wasn't looking at cars. He was looking at systems. Below him, automobile chassis moved down production lines in precise intervals. Workers stood at designated stations, each performing specific, repeatable tasks. One team installed engines, complete assemblies lowered by overhead cranes into engine bays in minutes. Another attached prefabricated door panels. Another connected electrical systems with standardized harnesses. No worker built an entire car. No craftsman supervised a vehicle from raw steel to finished product. Instead, Ford had broken automobile construction into hundreds of simple operations performed simultaneously across the factory floor. A complete car rolled off the line every 49 seconds. Bedford watched workers installing prefabricated components, dashboards assembled in separate workshops, seats built elsewhere, body panels stamped in different buildings, and saw something the automotive engineers probably didn't realize they were demonstrating. This wasn't about cars. This was about manufacturing logic itself. He returned to California convinced that ships could be built the same way. The revelation was almost obscenely simple. Instead of constructing vessels sequentially from keel to deck, each step waiting for the previous step to finish, why not break ships into major sections and build everything simultaneously? Bow sections fabricated in one workshop, stern sections in another, engine rooms assembled separately with all equipment pre-installed, deck houses constructed as complete units, cargo holds built as modular boxes. Then use massive cranes to lift these sections onto the building ways and weld them together like enormous steel puzzles. Parallel production instead of sequential construction. Bedford presented the concept to Kaiser, sketching diagrams that showed Liberty ships divided into 7 major prefabricated sections. Kaiser understood immediately. He had watched crews build Boulder Dam using exactly this logic. Concrete poured in massive blocks simultaneously across the dam face rather than layer by single layer. But when Bedford shared the concept with Todd Shipyard's engineers, the response was immediate and dismissive. Ships weren't cars. Maritime construction was fundamentally different from automotive assembly. The ocean demanded structural integrity that couldn't be achieved through factory gimmicks. Welding massive prefabricated sections together would create stress points and structural weaknesses. The comparison was absurd, ignorant civilians mistaking surface similarities for deep principles. John Riley, Todd's chief naval architect, delivered the most cutting dismissal. Automobiles travel on smooth roads at predictable speeds. Ships face storm waves that can exceed 40 feet and stresses that would tear any assembly line product to pieces. This isn't innovation, it's dangerous naivety. The traditional shipbuilders had centuries of evidence supporting their skepticism. Ships had been built sequentially since humans first hollowed out logs. The methodology had been refined across millennia, tested by countless ocean voyages, proven through generations of successful vessels. Kaiser listened to their objections, then quietly committed every resource at his disposal to proving them wrong. He had watched Ford's assembly lines transform automotive manufacturing. He had seen parallel construction techniques build dams that conventional engineers said were impossible. He understood something the maritime establishment couldn't see through their expertise. The rules governing how ships had always been built were not the same as the rules governing how ships could be built, and he was about to teach the world the difference. March 1941. United States Maritime Commission Headquarters. Henry Kaiser dropped a technical proposal on Vice Admiral Emory S. Land's desk that made the chairman's face turn the color of steel plate. Kaiser wanted to eliminate rivets entirely. For anyone unfamiliar with maritime construction, this requires context. Rivets were shipbuilding. Heated metal pins hammered through overlapping steel plates to join them together. The technique that had held ships together since the invention of iron hulls in the 1850s. Every major warship, every cargo vessel, every ocean liner that had ever sailed carried hulls joined by millions of individual rivets. The process was brutally labor-intensive. A skilled 4-man riveting gang, heater, catcher, bucker, and riveter, working with perfect coordination, could install perhaps 100 rivets per 8-hour shift. Each Liberty ship required approximately 1 million rivets if built conventionally. The mathematics were savage. Even with multiple gangs working simultaneously across different sections of hull, riveting alone consumed months of construction time. And riveting crews weren't interchangeable factory workers. They were skilled craftsmen who had spent years mastering the coordination required to heat rivets to precise temperatures, catch them in midair, position them correctly, and hammer them flush without damaging the hull plates. Kaiser proposed replacing this entire system with electric arc welding. Vice Admiral Land's response was immediate and hostile. His written correspondence, preserved in the National Archives, reveals the maritime establishment's visceral rejection. Welding has never been proven reliable for hull construction at this scale. The British Admiralty absolutely forbids welding on warship hulls due to concerns about structural failure under battle stress. Mr. Kaiser is proposing we gamble America's supply lines on unproven carnival technology. The resistance wasn't merely conservative caution. It was rooted in legitimate technical concerns. Welded joints could develop invisible stress fractures. Temperature variations during welding could create weak points. Traditional riveted construction provided redundancy. If one rivet failed, thousands of others held the hull together. A welded seam was continuous. A single fracture could theoretically propagate across entire sections. Naval architects who had spent careers studying hull integrity considered Kaiser's proposal reckless at best, potentially catastrophic at worst. But Kaiser had one argument the establishment couldn't dismiss: desperation. German U-boats were slaughtering Allied shipping. In 1941 alone, over 3.6 million tons would go to the ocean floor. Merchant vessels, tankers, cargo ships carrying food, fuel, weapons, and ammunition to Britain. The island nation was being systematically starved. British ports sat half-empty while dock workers waited for ships that would never arrive. American shipyards using conventional riveted construction averaged 230 days to build a single cargo ship. At that pace, the Allies would lose the Battle of the Atlantic before American industrial capacity could even respond. The statistics were brutally simple. Britain needed ships faster than traditional methods could possibly provide them. Land studied Kaiser's proposal with the cold arithmetic of strategic necessity. Welding was unproven. Riveting was proven but impossibly slow. The choice wasn't between safe and unsafe, it was between experimental technology and certain defeat. On March 19, 1941, Land approved Kaiser's contract with a single devastating caveat written in the margins. Approved under emergency wartime necessity. God help us if you're wrong. Kaiser had won permission to revolutionize shipbuilding. Now he just had to prove that centuries of maritime orthodoxy had been wrong all along. Richmond, California. January through December 1941. The Richmond shipyard rose from tidal mudflats on the eastern shore of San Francisco Bay like an industrial hallucination, something that belonged in Detroit, not on a waterfront. Kaiser's construction crews, experienced in building dams and highways, but utterly ignorant of maritime tradition, erected a facility that violated every principle of conventional shipyard design. And they did it in 11 months, a timeline that itself shocked an industry accustomed to multi-year construction projects. Traditional shipyards were arranged around massive longitudinal building ways with towering gantry cranes positioned to service ships, under construction from keel to superstructure. Workers moved to the ship. Tools came to the vessel. Everything oriented around the hull as the central, immovable object. Richmond looked like Ford's River Rouge plant transplanted to the waterfront. 7 parallel building ways, yes, but shortened, designed for rapid assembly rather than prolonged construction. Around them, vast open areas dedicated entirely to prefabrication. Massive workshops larger than airplane hangars where crews could build entire ship sections under shelter with proper lighting, climate control, and ergonomic positioning. Railroad tracks crisscrossed the entire facility in a web of steel, not ornamental, but designed to move sections weighing up to 150 tons from prefabrication areas to the building ways. Flat cars carried bow assemblies, stern sections, complete deck houses, engine room modules, pieces of ships moving through the yard like automobile components through a factory. And the cranes. Overhead cranes with lifting capacity that made traditional maritime engineers physically wince, positioned every 100 feet, capable of hoisting entire ship sections, 30, 40, 50 tons, and swinging them through the air with shocking precision. Equipment so excessive, so absurdly oversized for normal shipbuilding, that it seemed like industrial theater. John Riley, chief naval architect for Bethlehem Steel Corporation and a 30-year veteran of American shipbuilding, visited Richmond in May 1941 while the yard was still under construction. His confidential inspection report marked internal distribution only, oscillated between professional outrage and unwilling admiration. Kaiser has violated every principle of efficient shipyard layout I learned across 3 decades. His prefabrication areas are grotesquely oversized, wasting valuable waterfront space on workshops that belong inland. His crane capacity is wasteful. No traditional operation requires lifting power this excessive. His building ways are too short for proper longitudinal construction methodology. Yet I must acknowledge, with considerable reluctance, that the facility is designed with perfect internal logic for exactly what he claims: rapid assembly of large prefabricated sections. If his theory of modular construction proves viable, every traditional yard in America, including my own, will become obsolete overnight. Other inspectors filed similar reports: horror at the deviation from maritime orthodoxy, shock at the scale of prefabrication infrastructure, and beneath the technical criticism, something else: the dawning, uncomfortable recognition that Kaiser hadn't built a shipyard at all. He had built a ship assembly plant. The distinction mattered. Traditional shipyards were workshops where craftsmen built ships piece by piece, plate by plate, rivet by rivet. Richmond was designed around a fundamentally different assumption: that ships were products to be manufactured, not craft objects to be constructed. When the first workers arrived in August 1941, they walked into a facility that looked nothing like the romantic image of American shipbuilding. No grizzled masters teaching apprentices ancient skills, no forge fires heating rivets, no crews working in cramped spaces deep in partially built hulls. Instead, massive workshops, assembly line logistics, cranes moving steel, railroad cars delivering components. It looked like mass production, because that's exactly what it was. August 1941, Richmond, California. The first workers arrived at Kaiser's shipyard carrying lunch pails and uncertainty, but no maritime pedigrees. Traditional shipyards recruited from established maritime communities where skills passed father to son across generations. 4-year apprenticeships. Union cards earned through decades of dues and proving ground. Bloodlines that traced back to Scottish shipwrights, Norwegian craftsmen, New England boat builders. Kaiser placed advertisements in newspapers across America with a message that made the maritime establishment's blood pressure spike. No experience necessary. We will train you. Wages 20% above standard industrial rates. They came by the thousands. Women from secretarial pools and department stores. African Americans escaping the Jim Crow South and limited opportunities in northern cities. Dust Bowl refugees who had spent the Depression farming exhausted soil. Factory workers, teachers, ranch hands, shopkeepers, people who had never seen an ocean, much less understood the mystical craft of building ships. Mary Hester, a 23-year-old former grocery clerk from Oklahoma, arrived in Richmond in September 1941. Her training records, preserved in the National Archives, show the transformation. No mechanical experience, no technical education. Assigned to vertical bulkhead welding team. 14 days instruction. Productive welder by day 16 to 14 days, not 4 years. The secret was simplification through systematic task division. The same logic Ford had used to transform automobile manufacturing. Traditional welders spent years learning comprehensive maritime skills, how to weld in any position, on any material, under any conditions, reading complex blueprints and making independent technical decisions. They were craftsmen, and their expertise was real, valuable, and maddeningly slow to develop. Kaiser's training program destroyed this model entirely. Workers didn't need to know how to weld everything. They needed to know how to weld one specific thing that they would repeat thousands of times. Vertical seams on bulkheads, horizontal deck plates, curved hull sections, specific tasks with specific techniques taught through focused, intensive instruction. Instructors broke complex welding operations into simple, repeatable motions. Proper electrode angle, consistent travel speed, visual inspection criteria. 2 weeks of concentrated training on a single operation produced workers who could execute that operation as reliably as any maritime craftsman, and do it faster because they weren't making complex decisions or switching between different techniques. By October 1941, Kaiser employed over 10,000 workers in Richmond. Fewer than 200 had any previous maritime experience. The demographic transformation shocked traditional shipbuilders almost as much as the production numbers. Women comprised nearly a quarter of Kaiser's workforce. Rosie the riveters, who weren't riveting at all, but wielding welding torches on hull plates. African Americans found opportunities in Kaiser's yards that established maritime unions had systematically denied them for generations. Joseph James, a black welder from Louisiana, later recalled his first day at Richmond in a 1944 interview. The foreman didn't ask where I learned my trade or who my daddy worked for. He asked if I could hold a torch steady and follow a chalk line. I said yes. He said, "Then you're hired. Training starts Monday." This wasn't charity. It was industrial mathematics. Kaiser needed 10,000 workers immediately and couldn't wait 4 years to develop them through traditional apprenticeship systems. So he built a training infrastructure that could transform ordinary people into productive industrial workers in days instead of years. And it worked. These untrained civilians, dismissed by maritime experts as Kaiser's amateurs, were about to prove that skill isn't always inherited or slowly accumulated. Sometimes it's systematically created through good training, clear tasks, and the radical belief that ordinary people, given the right tools and instructions, can accomplish extraordinary things. The maritime establishment had spent centuries guarding their craft traditions. Kaiser was about to prove those traditions were obsolete. Richmond Shipyard, September 1941 through June 1942. The numbers told a story that traditional shipbuilders refused to believe until they couldn't deny it anymore. Ship number 1, 197 days. Kaiser's first Liberty ship, launched in September 1941, took longer than anyone wanted to admit. Nearly 7 months. Traditional yards watched with smug satisfaction. The dam builders' revolution was already failing. Richmond was barely matching conventional construction speeds despite all the expensive cranes and prefabrication theatrics. Ship number 2, 169 days. A month faster. Interesting, but hardly revolutionary. Learning curve effects. Nothing that challenged maritime orthodoxy. Ship number 5, 128 days. Now traditional yards started paying attention. 4 months was faster than most conventional operations, But Kaiser's workers were still mostly untrained. The speed couldn't be sustainable. Ship number 10, 97 days, 3 months. Alarms began sounding in established shipyards from Newport News to Bath Iron Works. Kaiser's amateurs were now matching the output speeds of highly skilled maritime craftsmen. The prefabrication approach that experts had dismissed as automotive fantasy was generating results that couldn't be explained away. By spring 1942, 70 days average, 10 weeks from keel to launch. Kaiser's Richmond yard was now systematically outproducing traditional shipyards that had been building vessels for generations. The acceleration wasn't gradual refinement. It was exponential improvement driven by parallel production, finally reaching full operational rhythm. Albert Wooding, production supervisor at Richmond Yard No. 2, explained the revolution in stark terms. In traditional shipbuilding, you cannot install the engine until the engine room is built. You cannot build the engine room until the hull is complete. You cannot complete the hull until the keel structure is finished. Everything happens in sequence, each step waiting for the previous step to finish. Kaiser's approach allows parallel production. While one crew welds hull plates together on the building ways, another crew assembles the complete engine with all its mountings, reduction gears, and condensers in a separate workshop. A third crew builds the entire deckhouse as a complete unit: walls, ceiling, doors, electrical conduits, ventilation, everything. When all sections reach completion, we use cranes to position them and weld them together. Tasks that previously required weeks now take hours. The statistics behind parallel production revealed efficiency that seemed to violate industrial possibility. Traditional shipyards might assign 50 workers to install an engine over 3 weeks, laboring in cramped, awkward spaces inside a partially complete engine room, working around obstacles, waiting for electricians to finish conduit runs, constantly repositioning equipment as other systems got installed around them. Kaiser's prefabrication approach assigned 200 workers to assemble the complete engine and its entire mounting structure in a well-lit, spacious workshop over 5 days. The engine, reduction gears, propeller shaft, condensers, pumps, electrical connections, steam lines, everything pre-assembled, pre-tested, pre-connected. Then massive cranes lifted the entire assembly, sometimes weighing over 100 tons, and positioned it into the finished engine room in a single 8-hour operation. Welding crews sealed it in place. Done. What had taken 3 weeks now took 1 day. Multiply that efficiency across every major ship system: cargo booms, deck houses, bulkheads, bow sections, stern assemblies, and the acceleration made perfect mathematical sense. Traditional yards watched the falling numbers with growing dread. Internal memoranda circulated among maritime executives, marked confidential, acknowledging the unthinkable. Kaiser's methods are proving viable at scale. Our conventional approaches may be obsolete, but the revolution was just beginning. Because if Kaiser could build Liberty ships in 70 days using parallel production and untrained workers, the question became inescapable: how fast could he build them if he really tried? Summer 1942. Richmond, California versus Portland, Oregon. Kaiser's shipyards turned speed into competition, and the entire nation started keeping score. By mid-1942, Kaiser operated multiple yards across the West Coast, 3 in Richmond, California, and 3 in Portland, Oregon. What started as industrial efficiency evolved into something else entirely: an informal, increasingly public race to see which yard could build Liberty ships fastest. Newspapers began printing ship completion times like baseball box scores. Richmond Yard, 2, 62 days. Portland Yard, 1, 58 days. Richmond Yard, 1, 6 days. The competition wasn't official. There were no trophies, no formal recognition from the Maritime Commission. But yard supervisors posted completion times on bulletin boards. Workers trash-talked rival facilities during shift changes. Foremen made side bets on which yard would break the next speed record. The race accelerated through the summer. Portland's Joseph N. Teal, 10 days. 10 days. From keel-laying to launch in a week and a half. The announcement hit traditional shipyards like a depth charge. A complete ocean-going cargo vessel built in the time-conventional yards needed just to install the propeller shaft. Newspaper headlines screamed the impossible achievement. Newsreel cameras captured the launch. Journalists treated it like a sporting event, because that's exactly what it had become. Admiral Howard L. Vickery, Vice Admiral Land's deputy at the Maritime Commission, immediately labeled the achievement a publicity stunt and issued stern warnings to Kaiser's management. His classified memorandum, declassified decades later, revealed the establishment's fury. These speed records serve no legitimate production purpose and risk compromising hull integrity through rushed construction. The Maritime Commission requires vessels built for durability and safety, not newspaper headlines. Further record attempts will result in enhanced inspection protocols and potential contract penalties. Vickery's concern wasn't entirely unreasonable. The Maritime Commission needed ships that would survive Atlantic crossings and U-boat attacks, not publicity props that might fracture in heavy seas. Speed records created pressure to cut corners, rush welds, skip quality checks. But Kaiser's yards had already anticipated this criticism. Every record ship underwent the same rigorous inspection protocols as standard builds. Naval inspectors crawled through every compartment, tested every weld, verified every system. The Joseph N. Teal passed every certification and went on to complete multiple Atlantic crossings, carrying critical war cargo. The speed wasn't achieved through shortcuts. It was achieved through ruthless optimization of parallel production, pre-building absolutely everything before keel-laying, coordinating over 1,000 workers in tightly synchronized operations, using every crane simultaneously, running triple shifts without breaks. It was industrial choreography performed at a scale that made traditional shipbuilding look like slow-motion theater. Richmond responded to Portland's 10-day record with competitive fury. Yard supervisors studied production logs, identified bottlenecks, refined prefabrication sequences. Workers volunteered for extra shifts. The informal competition became deadly serious. And despite Admiral Vickery's threats, the Maritime Commission couldn't actually stop it, because the stunts were producing fully functional ships that the Allies desperately needed. Traditional shipyards watched this spectacle with professional horror. Speed competitions, newspaper coverage, workers treated like sports teams. It violated every principle of dignified maritime craftsmanship. But it was working. By late summer 1942, the mindset shift was complete. Extraordinary speed wasn't a stunt anymore. It was the new normal. Kaiser's yards were averaging 45 days per ship. Workers who had never seen an ocean 8 months earlier were now building cargo vessels faster than maritime masters thought physically possible. The race between Richmond and Portland had accomplished something beyond fast ships. It had permanently shattered the psychological barrier that kept the industry imprisoned by tradition. If Liberty ships could be built in 10 days, then every assumption about normal construction timelines was a lie. And if those assumptions were lies, then what else had the experts been wrong about? The answer was about to get even more shocking. October 1942, Richmond Shipyard No. 2, Vice Admiral Emory S. Land made an offhand remark during a Maritime Commission meeting that would trigger the most audacious manufacturing experiment in naval history. Reviewing quarterly production statistics, Land observed that while Kaiser's shipyards had achieved remarkable speed improvements, shipbuilding still lagged behind other American mass production industries. Aircraft factories were producing bombers in days. Tank plants were churning out armored vehicles in hours. Even with Kaiser's innovations, ship construction remained measured in weeks rather than days. It was analytical observation, not criticism. Clay Bedford heard it as a challenge. Kaiser's chief engineer had spent 18 months perfecting parallel production techniques. He had watched construction times fall from 197 days to 70 days to 45 days. He had seen Portland build the Joseph N. Teal in 10 days, and he believed, no, he knew, that the theoretical limit of Liberty ship construction hadn't been reached, not even close. Bedford selected hull number 47 for the attempt. The designation would become SSS Robert E. Peary. The choice wasn't random. Yard 2 had the most experienced crews, the most refined prefabrication processes, the best track record for coordinated operations. But this wouldn't be a normal build, even by Kaiser's revolutionary standards. Bedford's plan was brutally simple. Pre-build everything before the keel ever touched the building ways. Every major section, every minor component, every system, subsystem, and piece of equipment fully assembled, tested, and staged for immediate installation. The hull would be assembled like a giant jigsaw puzzle with all pieces already cut, fitted, and ready. Traditional shipbuilding treated keel-laying as the beginning of construction. Bedford treated it as the final assembly stage. The preparation consumed weeks. Across Richmond's massive prefabrication workshops, over 1,000 workers built the Robert E. Peary in pieces. Complete bow section with frames, plates, and reinforcements welded into a single 40-ton unit. Complete stern assembly with propeller shaft, rudder post, and structural supports integrated. Entire engine room module, turbines, reduction gears, condensers, pumps, piping, electrical systems, assembled and tested as a functioning unit weighing over 100 tons. 7 cargo hold sections built as complete boxes with bulkheads, deck plates, and framing. Full deck house with crew quarters, galley, navigation bridge, radio room, walls, doors, electrical conduits, ventilation, everything finished. Cargo booms, masts, winches, lifeboats, anchor windlass, every piece of deck equipment prepared for immediate mounting. The logistics were staggering. Every section had to be precisely dimensioned to mate with adjacent sections within tolerances measured in fractions of an inch. Welding teams had to coordinate across dozens of simultaneous operations. Crane operators had to choreograph lifts timed to the minute. Bedford created shift schedules that read like military operation orders. Teams designated by color codes: red team on bow sections, blue team on stern, green team on engine installation. Supervisors carried clipboards with minute-by-minute timelines. Backup crews stood ready to relieve workers without stopping operations. This wasn't shipbuilding anymore. It was industrial theater performed at a scale that would either prove Kaiser's entire philosophy or spectacularly demonstrate its limits. On November 8, 1942, at midnight, Bedford gave the signal. The keel of the SS Robert E. Peary touched the building ways. The clock started, and over 1,000 workers began assembling a Liberty ship with the coordinated precision of a symphony orchestra playing at triple speed. Welding torches firing, cranes swinging massive sections through the air, railroad cars delivering components in continuous streams. Traditional shipbuilders would have 4 days to watch their entire worldview collapse. November 8, 1942, midnight, Richmond Shipyard No. 2. The keel of the SS Robert E. Peary settled onto the building ways under floodlights that turned night into industrial day. Clay Bedford stood on the observation platform with a stopwatch, surrounded by supervisors holding production schedules measured in minutes, not days. The clock started. What followed looked less like shipbuilding and more like controlled industrial chaos, orchestrated with surgical precision. Hour 1. Massive cranes swung the bow section, 40 tons of prefabricated steel, through the air and lowered it onto the keel with shocking gentleness. Welding crews swarmed the connection points, torches igniting in sequences that looked almost choreographed. Hour 6. Stern section positioned. The basic hull skeleton now visible, front and back connected by the keel spine, waiting for its body. Hour 12. First cargo hold sections descending. Complete boxes measuring 30 feet on each side, built as integrated units in workshops, now being fitted into place like massive steel Lego blocks. Welders moved in coordinated teams, sealing seams, while the next section was already being positioned overhead. Day 2, the hull took shape with terrifying speed. More cargo holds, bulkheads, internal framing. Deck plates lowered in prefabricated panels, measuring hundreds of square feet. What would have taken conventional crews weeks to rivet together now welded in place within hours. Day 3, Hour 14. The engine installation. The operation that defined Kaiser's parallel production philosophy. 200-ton cranes lifted the complete engine room assembly. Turbines, reduction gears, condensers, pumps, propeller shaft, all pre-connected and tested, and lowered the entire mass into the finished hull cavity. An operation that would have taken traditional shipyards 3 weeks of cramped, awkward labor executed in 8 hours. Workers guided the descent with ropes. Engineers aligned mounting points. The assembly touched down. Welding crews sealed it in place. The heart of the ship installed while most of America slept. Day 4. Superstructure rising. The deckhouse, complete with crew quarters, navigation bridge, galley, radio room, lifted as a single unit and bolted to the main deck. Cargo booms mounted. Masts positioned. Lifeboats hung. Anchor windlass connected. November 12, 1942. 3:30 p.m., 4 days, 15 hours and 29 minutes after the keel touched the building ways, the SS Robert E. Peary slid into San Francisco Bay. Not a hull, not a partial vessel, not a publicity stunt. A complete, fully operational cargo ship certified by naval inspectors, equipped with functioning engines, loaded with safety equipment, ready for immediate war service. The crowd that had gathered to witness failure stood in stunned silence. Vice Admiral Emory S. Land, the man who had approved Kaiser's first contract with deep skepticism, who had resisted welded construction, who had called prefabrication experimental, stood before newsreel cameras and delivered a statement that Maritime Commission aides would later try to soften in official transcripts. Henry Kaiser has made traditional wisdom obsolete. What we believed about shipbuilding limits, the timelines we accepted as inevitable, the methods we considered essential, were not laws of physics. They were failures of imagination. This vessel represents not incremental improvement, but complete transformation of industrial possibility. The Robert E. Peary would go on to complete multiple Atlantic crossings, survive U-boat attacks, deliver thousands of tons of war cargo, and serve until 1963, proving that speed and durability weren't mutually exclusive when engineering replaced orthodoxy. But the ship itself almost didn't matter anymore. What mattered was what it represented. The death of impossible. 4 days, 15 hours, 29 minutes, from keel to launch. Traditional maritime wisdom hadn't just been challenged. It had been annihilated. December 1942 through March 1943 established shipyards across America. The engineers arrived at Richmond quietly without fanfare or press coverage. Bethlehem Steel. Newport News Shipbuilding. Bath Iron Works. Todd Shipyards. Sun Shipbuilding. The oldest, most prestigious maritime construction firms in America, sent their best technical minds to study what the dam builder had accomplished. They came as observers. They left as converts forced to confront an uncomfortable truth. Everything they believed about shipbuilding had been wrong. The internal reports they filed, marked confidential, never intended for public release, read like confessions. From Bethlehem Steel's Technical Assessment, January 1943. Kaiser simplified where we sought perfection. We designed custom solutions for each vessel variance. He standardized everything: hull sections, deck layouts, equipment specifications. We believed customization demonstrated superior craftsmanship. He proved that standardization enables speed. And in total war, speed is superior craftsmanship. From Newport News, Shipbuilding's Engineering Review, February 1943. Kaiser eliminated complexity we considered essential. Our welders train for 4 years to handle any situation. His welders train for 2 weeks to handle one specific task repeatedly. We believed comprehensive skill was irreplaceable. He proved that specialized repetition produces faster results with lower error rates. Our superior workforce cannot compete with his systematic approach. From Bath Iron Works Confidential Operations Report, March 1943, we must acknowledge the brutal mathematics. Kaiser's untrained amateurs now outproduce our master craftsmen by factors of 3 to 1. His prefabrication approach, which we dismissed as automotive fantasy, has proven devastatingly effective. His parallel production methods achieve in days what our sequential construction requires weeks to accomplish. Recommendation: immediate adoption of Kaiser methods or accept irrelevance. The reports shared common themes that read like industrial obituaries. Traditional shipyards had optimized for quality over quantity. Kaiser optimized for adequate quality at massive quantity, and proved that in wartime, good enough by the thousands beats perfect by the dozens. Traditional yards had protected craft traditions and guild knowledge. Kaiser had systematized everything, making implicit expertise into explicit procedures that anyone could follow. Traditional shipbuilders had treated each vessel as a unique creation requiring experienced judgment. Kaiser had treated ships as products requiring standardized processes. And Kaiser's approach was winning. By spring 1943, the Maritime Commission made Kaiser's methods mandatory across American shipbuilding. Not suggested, not recommended. Mandatory. Prefabrication zones, welded construction, simplified training programs, parallel production schedules, standardized Liberty ship designs with zero customization. The techniques that established yards had ridiculed 18 months earlier became federal requirements that traditional builders had to adopt or lose government contracts. John Riley, Bethlehem Steel's chief naval architect, who had inspected Richmond with barely concealed contempt in 1941, filed a final assessment in April 1943 that captured the industry's ideological collapse. We were custodians of a craft tradition spanning centuries. We believed our experience and expertise made us irreplaceable. Henry Kaiser, who knew nothing of our traditions, proved that our expertise had become a prison. He saw shipbuilding not as sacred craft, but as engineering problem amenable to systematic solution. We were wrong about riveting, wrong about workforce requirements, wrong about construction timelines, wrong about nearly everything we held as fundamental truth. The most devastating realization: our decades of experience made us blind to possibilities that an outsider saw immediately. Kaiser's ignorance was his advantage. Our expertise was our limitation. The transformation happened with shocking speed. By mid-1943, 18 American shipyards were building Liberty ships using Kaiser's methods: prefabrication, welding, simplified training, parallel assembly. Average construction time across all yards, 42 days. Peak production, 3 ships per day launched from American yards. The old guard hadn't just lost an argument about methodology. They had lost their entire world view and been forced to admit it in writing. 1940–1945 American shipyards, Atlantic Ocean. By mid-1943, 18 American shipyards operated as synchronized weapons of industrial warfare. Richmond, Portland, Baltimore, Savannah, Houston, Los Angeles. Yards that had adopted Kaiser's methods, some willingly, others under federal mandate, now functioned as a distributed manufacturing system producing Liberty ships with assembly line efficiency. The statistics told a story that German naval strategists initially refused to believe. Average construction time across all yards, 42 days. Peak production rate, 3 complete Liberty ships launched per day. 3 ships, every single day. 441-foot cargo vessels capable of carrying 10,000 tons of war material each. Welded hulls, prefabricated sections, crews trained in weeks instead of years. The entire American shipbuilding industry transformed into a machine that produced tonnage faster than the Axis powers could sink it. The strategic implications were catastrophic for Germany. Admiral Karl Dönitz, commander of Germany's U-boat fleet, had built his entire Atlantic strategy on brutal mathematics. Sink Allied merchant ships faster than shipyards could replace them. Starve Britain. Sever American supply lines. Force negotiated peace through industrial attrition. The strategy had been working. Through 1941 and early 1942, U-boats sent Allied tonnage to the ocean floor at rates that should have been unsustainable. Over 1,600 merchant ships sunk in 1942 alone. Nearly 8 million tons of shipping destroyed. But Dönitz's calculations assumed traditional shipbuilding rates. He assumed each sunk cargo ship represented 6 to 8 months of Allied industrial capacity. He assumed merchant marine losses would accumulate faster than replacements could arrive. He hadn't accounted for Henry Kaiser. By late 1943, American yards were replacing sunk tonnage faster than U-boats could destroy it. German submarines might sink 5 merchant ships in a week, and American shipyards would launch 15 in the same period. The mathematics of industrial warfare had inverted. Dönitz's own war diary, captured after Germany's surrender, revealed the moment of realization. An entry from November 1943 read with chilling clarity. Intelligence reports indicate American Liberty ship production now exceeds our entire merchant sinking capacity. We are no longer degrading Allied supply capabilities. We are merely providing target practice for an industrial system that replaces losses within days. The tonnage war is lost. The Battle of the Atlantic, the longest continuous military campaign of World War II, wasn't won primarily by destroyers, depth charges, or code-breaking, though all contributed. It was won in the shipyards. Kaiser's revolution had transformed industrial capacity itself into a strategic weapon. Allied planners could now accept shipping losses that would have been catastrophic in 1941, because they knew replacements were already sliding into the water from Richmond, Portland, and a dozen other yards. By 1944, Liberty ships crossed the Atlantic in vast convoys carrying tanks, aircraft, ammunition, fuel, food, and troops, the material foundation of Allied victory in Europe. U-boats still hunted them. Some ships still went down. But the industrial tsunami overwhelmed German interdiction capacity entirely. The final numbers revealed the scale of Kaiser's impact. 2,010 Liberty ships built between 1941 and 1945. Over 27 million tons of shipping delivered. More tonnage launched in 4 years than had been built in the previous 2 decades combined. Admiral Ernest King, Chief of Naval Operations, summarized the transformation in his post-war assessment. "We did not defeat the U-boat threat through superior naval tactics alone. We drowned it in American industrial capacity. Henry Kaiser's methods turned shipyards into weapons more decisive than any destroyer or aircraft carrier. The Battle of the Atlantic was won not at sea, but in the prefabrication workshops of Richmond, California. Germany had bet on industrial attrition. America had responded with industrial revolution, and the revolution proved more powerful than any submarine fleet could overcome. Fortive and beyond. Kaiser's revolution didn't end with victory. Post-war Japan and South Korea, rebuilding shattered economies, adopted Kaiser-style modular shipbuilding as foundational methodology. By the 1970s, Asian shipyards using prefabrication and welding techniques pioneered in Richmond dominated global maritime construction, an ironic legacy that Kaiser himself acknowledged with pragmatic respect. Prefabrication logic spread beyond shipyards. Bridge construction, industrial plants, even housing developments embraced modular assembly. The Levittown suburbs that defined post-war American housing used prefabricated components and simplified construction techniques borrowed directly from Kaiser's wartime innovations. Kaiser's prepaid healthcare system, created to attract workers to remote shipyards, evolved into Kaiser Permanente, one of America's largest healthcare organizations, serving over 12 million people by the 21st century. Perhaps most significantly, the women and minorities who flooded Kaiser's yards during wartime took industrial skills into peacetime economies. Women who had welded Liberty ships became factory supervisors, trade instructors, small business owners. African Americans who found opportunity in Richmond used that experience to challenge discriminatory hiring practices across American industry. Kaiser had built ships, but he had also built a template for industrial transformation that reshaped manufacturing, healthcare, and labor markets for generations. The techniques that won World War II became the foundation of post-war prosperity. The lesson: this story was never really about ships. It was about the word impossible, and the damage that word inflicts when experts wield it as truth rather than admission of limited imagination. Henry Kaiser proved that most limits aren't physical. They're organizational, cultural, psychological. The barriers built by people who mistake tradition for inevitability and experience for wisdom. Traditional shipbuilders weren't incompetent. They were imprisoned by expertise, unable to see past methods that had worked for centuries, unable to imagine that how we've always done it might be the problem rather than the solution. Kaiser's ignorance became his superpower because he asked the questions experts had stopped asking: why and why not? And when he paired that questioning with systematic thinking, breaking complexity into simple, repeatable tasks, trusting ordinary people with proper training and tools, optimizing for speed over perfection, he accomplished what maritime masters called impossible. The workers who built the Robert E. Peary in 4 days weren't superhuman. They were ordinary people given extraordinary systems and the radical belief that they could succeed. Henry Kaiser didn't just build Liberty ships in 4 days. He built a new definition of human potential and left the word impossible on the scrap heap where it belonged.